Introduction. Consequentialism is a moral theory that focuses on outcomes of action. In plant genetic and breeding, this is important when considering technologies like genetic modification and PR. While this method offer benefit like higher crop yield and resilience, they also raise ethical concerns such as ecological balance, gene ownership, and long-term sustainability. The main issue is whether the long-term effect, both positive and negative, are ethical acceptable, especially in terms of their impact on the environment and society.
For literature review, sustainability in plant breeding involves balancing people, focusing on health benefits, planet, aiming for higher yields with fewer resources, and profit, ensuring better yields and reduced waste. Challenges include herbicide tolerance and high GMO costs. Next, biodiversity. Biodiversity in palm breeding is crucial for ecosystems and genetic diversity. Challenges include genetic bottlenecks and limited crop variety. Efforts to conserve diversity involve institutions like the Center for Genetic Resources in Wageningen and support for European protein crops. Off-target effects in plant breeding occur when undesirable traits appear. While gene editing offers targeted improvements, traditional breeding often causes more unintended side effects. Next, social justice. Plant breeding has operated under a breeder's assumption, allowing free access to varieties. However, high gene editing costs may limit smallholder access.
Let me begin with a key ethical question through the lens of consequentialism or consequence ethic, which evaluates action based on their outcomes. Do modern precision breeding technologies like gene editing and genomic selection truly lead to the greatest good for people and the planet? Or do these innovations unintentionally harm biodiversity, ecosystem, or social justice? Let's explore this through a SWOT analysis. First, the strength. Precision breeding increases productivity without needing more lands, and biofortified crops help fight malnutrition. Climate-smart cultivars withstand drought and heat, reducing crop failure, and new tools like CRISPR are also faster and cheaper than traditional GM methods. But their weakness, which is over-reliance on high-yield crops, may reduce biodiversity, and some added crops increase herbicide use, and high R&D costs and strict patent limit access for smallholders and public breeders. Opportunities include growing public-private partnership, policy reforms to ease regulatory burdens, and open-source licensing that promotes equity and innovation. Threats include public distrust, regulatory barriers, and market monopolies. In the global south, issues like biopiracy and marginalization of traditional knowledge raise concern about fairness and long-term dependency.
Is the application. Ethical plant breeding should aim to benefit everyone, especially smallholder farmers, by promoting food securities and fairness. We must minimize environmental harm, avoid biodiversity loss, and ensure sustainability practice. Also, safety checks are essential before releasing genetically modified crop. And lastly, public engagement and transparency are key to building trust and making informed decisions.
Overall, consequentialism supports gene editing in plant breeding for its benefits, but urges careful consideration of its long-term environmental and social impacts. The recommendations is, first, implement ethical regulations, second, promote equitable access, and the third one is monitor long-term effects.